Okay, so hello everybody, I'm Tonimir from in Croatia. I head the laboratory for open systems and security at my faculty. And well, this is my talk and I'll show you how to use better methods for password cracking. So, we are no strangers to such headlines. We all know about RockU, about how LinkedIn was hacked. We all know how Adobe's passwords leaked. Target password leaks. Every day, every month we have at least some, which is good. We have more research data. And most of you really don't know why should you care if passwords leak, why should you care about passwords? Well, first thing, passwords are the most widely used authentication method. But since security is a depressing affair, and mostly security everywhere is pretty bad, when attackers compromise one host and get hold of your passwords, they'll try them against other hosts. They'll try to do anything to increase their foothold into other networks and try to hack more. So when I say hackers, I don't mean positive hackers, I mean bad ones, right? So the good thing is when they do password cracking, they use bad lists. Well, why should we even care? First thing, if you don't test your systems for bad passwords, if you don't see if there are bad passwords on your machines that you maintain on your accounts, don't worry. The kind people in the internet will test it and usually they will infect your machine. We will see in a couple of moments that even botnets and automated attackers have really good methods to crack passwords. So, first off, let's start by the psychology of passwords. The first case would be an ideal password. I hope everybody of you can remember it. But real passwords that common users use, we know that the best password was password 123456. This changed right now, and since complexity requirements are pretty big, the most common password right now is password in first uppercase, then an exclamation mark. So it passes all password complexity checks. And there are, of course, default passwords on all kinds of systems that will also be mentioned here. So since I have to make a mandatory XKCD reference, if any of you needs to choose a password, use passphrases, seriously. They're simple. Don't use correct force battery staple because that's on the first list of passphrases to test. Imagine one that is totally insane, that isn't common, that isn't used anywhere, and use it. Second thing, don't reuse passwords. Don't use the same one at 2 or 3 places. First off, we'll start by default passwords. So why should we care about default passwords? Because most of the devices that are connected to today's networks, like routers, switches, access points, embedded devices like, I don't know, you'll hear in about 2 lectures there will be an embedded talk. They tend to be forgotten. Somebody leaves an access point unconfigured. Some people just put them in a network to test, and they usually are sloppy configs. So they give a foothold into your network that can be rather exploited easily. But the biggest problem with hard-coded, with initial passwords are hard-coded backdoors. I don't mean that you have an account that is named root, so you can change the root password and everything is fine, but we have even more and more hard-coded backdoors into all kinds of systems. So these are from the last month because the list would be too big to just maintain all of them. At Black Hat there was a talk about hacking the TSA, the airport security, and they found out by reversing some devices that they use that, for instance, access control that can tell you which people and which officers are on the floor has a default user, super user, and a default password. I have a HP storage device in my laboratory, which is a SAN storage, and there was a leak a couple of months ago that HP installed backdoors into all storage systems. So I tried it, HP support in Badgers, in Elite, of course, and I get access to the root account of my storage. You cannot change this password, you cannot edit it, you cannot disable it, it's there. So that's pretty depressing. But the part I found most funny and most interesting is the little device in the picture here. For instance, Airport security uses devices to test for narcotics and explosives, so they can swab you and see if you have any explosives and any narcotics. They are, of course, connected to the networks. And, oh, happy, they have default backdoors which cannot be changed. So, as I said, it's pretty depressing and pretty bad. Where can you find some of this stuff? I'm going to tell you about a project. All of these things can be used, weaponized, and used in your testing. So it's called Unhash. It is developed as a part of my research into passwords and a result of my thesis. You can get it on GitHub. And my idea is to contribute elements of it into other tools. So trickle-down economics, right? It consists of a couple of tools. First is default passwords, which I talked about, where you can download all default passwords from a multitude of lists. The second is collecting user and password lists from known botnets and known attackers. Third one is about scraping the internet to find data to use in attacks. And fourth one is a guided rule password cracker, which will pass. So the main idea of this is this should be secure, create host brittle staple, just write a rule like that, run it, and you'll probably guess it in a minute or two. So let's get the first one. You want to get default user and password pairs for default devices, default backdoors. My approach to that was not manually collecting it, but writing a scraper that scrapes multiple known lists out of the internet, like PhenoElite, Liquid Matrix, DexCMS, CertNet. Weight them by occurrence, merge them, and you have a pretty much a good list to test for default backdoors, default passwords. I usually maintain some additional extras in there. You can use it with Metasploit, with Hydra, with any other tool that you like. It's available in Unhash as default passwords. You can update those lists manually, or Metasploit framework already has the list. It's known as default user password services, and you can use it already because it's committed into Metasploit framework. If you, of course, trust my maintenance of the list. The second one is, I said, botnets. For instance, there are a lot of targeted attacks against passwords that attackers use or that are automated via botnets, via scanners, or something like that. So the idea was how to collect as much as data from attackers and get their user password pairs so we can test our systems against their attacks. Well, I found out an interesting site that's called SSHbot, which collects data from SSH honeypots. So if you run an SSH honeypot, ship data to them, they'll make it available to the world. And it's interesting because it enables you to see IP addresses of the attackers, and it enables you to see what username and password pairs they used. And it's nice in JSON, you can parse it easily. So you can use the bot pass tool in Unhash to test against common attackers. So you have a fingerprint of how attackers attack those systems and which password list they use. This should be, of course, interesting to everybody because we want to detect those weak passwords. And the third one, those two attacks are against online systems where you have, for instance, a network device. What happens if you have password hashes handy? So you want to test against local hashes. You have an attack that you need to work offline. Well, that's the last part, which is the most interesting. These ones are pretty much to cover the other part. What happens when you want to identify passwords? Usually we have rule sets. Take something, do a mutation, add something in the back. Well, I took a different approach, and I checked out all collected lists that I had, except LinkedIn and a couple of others that we used for testing and verification. And I checked about 14 million unique passwords that are 33 million passwords in common. And a few patterns started to emerge. First, people use all kinds of interesting passwords. Passphrases are one, but there are some others, like weak patterns. I saw a password, I said, whoa, that's a strong password. And then I figured out somebody just pressed shift and went 0987 YOIOP. like diametrically or some other way on the keyboard. So a lot of people use passwords that are generated by just drawing a pattern on the keyboard. Some people use patterns like XA, 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 which are also weak. Some people insert stuff. For instance, you have balcon and you insert exclamation marks after every second character. There are a lot of passwords that use symmetric elements. For instance, 123 password 123 or 123 password 321. And that's the easy part, but the interesting part is when you see how people combine passwords and how do they mutate them. So combination is combining two words, or a word and a number, word and a symbol, and how do they change them? How do they mutate them? And also there are simple things, like a simple word, like a simple symbol or a number. To get an idea how people create passwords and how do they identify them, I developed a simple algorithm that's called sieving. It's in the process of publication. It will be probably dumped on GitHub in a few days. It's a classification to take a password and see how it is created, what's the recipe for that password, right? And since you can disassemble a password into its parts and see what mutations are, how it's combined and created, why not mine for all elements? So if you have, for instance, a password 1 exclamation mark, why not mine somebody used password, somebody used 1, somebody used the exclamation mark at that point in that combination, which would be interesting because if you collect the data for 33 million passwords, you can see all kinds of patterns that will help you do better attacks, right? The problem here is how do you identify words, how do you identify languages, how do you identify that a password is a password? How do you identify that, for instance, rakia is a word in Serbian or Croatian that is used as something? That way, a linguistical database needs to be constructed, and if you want to identify words or do any natural language processing with a computer, it's pretty much difficult. Why? Because normal linguistical databases, like Google's Ngram database, or for instance, any other linguistical corpora are pretty much formal. What happens is that scientists don't use slang. Scientists don't include some words that are made up in the process of our natural language. So what happens? When you want to try a good linguistical data set, you don't have a lot of options. So what I did, Wikipedia maintains bezipped database backups. And those backups are in XML. So parse a couple of gigs of Wikipedia content and create a table of tagged words, for instance, in which languages they occur and how many times they occur. You put it in Postgres and you get about 20 gigabytes of data in Postgres, and to fasten searches you use trigram and gene indexes to enable faster searching. This pretty much solves the problem of if you want to see rakia, that somebody will say Croatian, Serbian, probably other languages, but you'll know it's a word. And if somebody says rakia rules, that means Croatian, Serbian, English, and you know it's a combination of two words. It's interesting, but when you sieve data like this, you'll get a lot of unique passwords that yield models how users create them, right? So, for instance, check out this here model. This is a sieve of, let's see, a bigger password that looks really strong and really secure, but it's not. It's a usual keyboard pattern, right? We want to have this here pattern. And second example is foi 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 foi, which is the shorthand of my faculty. It's also a weak pattern which can be created by 3 times applying the shorthand of my faculty. But let's see how it looks if you use a complicated password, right? So as we can see here, 19084 complicated something. It would be first use 184, that's a sequence. After that, replace I with 1, O with 0, that's a mutation. Apply it on a word that's named complicated, which is available in English, German, Spanish, French, Croatian, Italian, and Netherlands. It's since it's merged from Wikipedia, you can't really be certain of a root of a word, right? But you can get it in multiple languages. You get the length, occurrence, and statistical data, and after that, the end sequence. What's the interesting part? You store each part separately. For instance, the words, the years, the word that was used, the mutation, the suffixes, everything. So actually you know how the user created the password, and you know which data he used. So as a unhashed rule, this would look like this. Number length 4, add a dictionary 11, replace this with this, and then add a string with length of 4. This will enable you to use any word list that you want, and the parts that I've shown here, like number length 4, it's not a generated, it's not brute force generated. Use any 4 numbers. Use data. We use data collected from those from the learning process, and then augment it with parts that are not available in the dictionary, right? So that enables us to first try things that are more probable than things that are not probable. What's the benefit of those models that I just shown? Is because they don't discriminate word lists, and they're, in my humble opinion, they are simpler than John rule sets or Hashcat rule sets, because you can easily write rule sets like that and explain even more complex cracking things. So first one is when you have data collected from analyzing passwords, you merge them with Wikipedia based on the spread, so you can pick up all other words in between. And the second idea is, since you use the first as a last resort, why not obtain a word list that explains or describes a person, right? For instance, if you want to attack me, you all know that I'm from Varaždin, that I work at the Faculty of Organization Informatics, that I like security, cryptography, passwords. You can pretty much find a lot of keywords about me on the internet, right? So what you're gonna do? How will you obtain a word list that is specific to me? Well, that's where another tool comes in, called GWordList, which means Google Word List, which you write top N keywords like Tonimir Kisasondi Force, password cracking, password security, hacking, laboratory, something, and you scrape top N Google results based on your keywords or Google Docs, and it will create resultant word list using the text. The interesting part is it uses Google Docs, so any Google hacking docs you know can be already used as a keyword. For instance, you want to limit it to creation pages, you just enter site $.hr and it will limit it to creation pages. And when you get that word list, you can also recurse on that every keyword from that word list and create even a larger word list. This is interesting because you can get pretty good data out of it. For default attacks, you have all the rule files and word list already available on GitHub, which would mean that the whole project comes with batteries, or if you like it, more bullets included. There's also an interesting part because in the process of trying out this stuff, I was interested to see if why Python is slow. So if you look at the source code in Python, and if somebody is Python performance ninja, I would like him to take a look at the source code, because the normal Python interpreter is really slow. So I used PyPy, which helped considerably. And you can use it with a rule file and just pipe it into John or Hashcat or any other tool you like, and it will do it. So let's talk about results, right? I'm leaving time at the end so I can show you the lists, I can show you the tools, but let's see about results. If you use LinkedIn list as a benchmark, which the tool wasn't learned on LinkedIn, so it was learned on other lists, and you have the LinkedIn list as a testing parameter. There were multiple tests, I just took LinkedIn as an example, and you add keywords: LinkedIn, business, recruiting, networking, job, contacts, run gword list and use that word list in conjunction with other word list, and run jumbo John version 179 all settings, and then run unhash, you'll get about 20% performance enhancement. It's not a lot, or depends on how you look at it. If you have a lot of passwords, you probably find some others that John missed. If you have a diff of the passwords, you'll see that the ones that are shown are usually complex ones obtained from the combination of some other keyword, and they wouldn't be tested. So, before the conclusion, I would like to show you how it works. Oh, nice, it's mirrored already. You can get it on GitHub. You can get all these scripts out normally. You can download them and show them. How does a unhash rule look? So I'm going to show the example file first, right? All rules are basically Python scripts. You can write normal Python code and it will get executed, and you can use it in your password cracking attacks. For instance, if you want to open a file and just dump everything from a file, you would give him a keyboard F, file, open keywords, txt, and just dump everything out of it. If you want to take two words and combine them, if it's from the same dictionary, you can just open an array, say keywords, comma, second keyword, and it will do a Cartesian product of that list. You can use two lists, you can use three lists, whatever. Adding specifics is normally just add a string, it will add a string in the middle. You can add all kinds of stuff. You can use uppercases, which letters you want uppercase. Do you want to uppercase everything, just the first two ones? Do you wish to all except the last two? You can do slices. For instance, you want to cut away first two characters and leave a slice of some characters. You want the last three characters. You can do all kinds of stuff. You can reverse strings. And I think those rules are pretty much simpler than John rules, because you can say, here's a word list, replace S with 5, O with 0, and permutate all possible combinations. For instance, do it normally, just select the first letter, the second letter, all letters. It will do a lot bigger coverage, right? So you can use all those things, or generate, even do brute force attacks. For instance, instead of a file, you say generate length to all of these words, right? You can give it a variable, anything you like. I think you can do all kinds of stuff. So how do people create the rules? So this is the rule set that is created by data mining real passwords, and it is here. So you see that people like 6-letter dictionary words the most. After that, 6 numbers. 7 letters dictionary, adding 2 numbers, 5. You can see the data here. If somebody is interested, I can send you the whole data set, which is weighted, and you can have results on how many times a concrete model was found, but I didn't leave it because leaving everything, including the linguistic parts, takes about 550 gigs, something like that. So if somebody wants, I can hook you up, right? So this is pretty much how the rules look, right? And that's the part I said, that the source code looks horrible, right? But it didn't know how to performance enhance Python enough to make it good, right? The dictionaries and everything are also included in the project. So you can get the dictionaries, you can get word lists that are used here, and you can just do a git clone and it will be updated with the latest lists as I'm working on it. So you'll get the latest updates if I change something, right? So let's go on to the conclusion, and we'll have some time left for Q&A and to discuss about these things, what is interesting to you. It's on GitHub, have fun, don't be evil. Don't use it for evil. We know, seriously, we know passwords suck, but that's not a new stuff. And passwords are the best thing we currently have. And yeah, two-factor authentication is cool. Biometrics suck because they are non-revocable unless you have a small hatchet. And all thing we have is smart cards and tokens, right? Use salted passwords, salted passphrases if you must, if you develop systems. And other contributors are welcome if you have some ideas what you would like to improve or something. I would really like a couple of ideas about that too, right? So I'm ready for questions if you have any. Yeah.
Could you go back to the table with the results?
Okay.
I didn't quite get the results. So what's the total?
So the total was about 2 million passwords, something like that. That's part of the part of the LinkedIn list that was verified as valid,
Yeah.
right?
Those are the hashes, and this is
Yeah.
the
So
percentages.
yeah, but the results are in 24 hours. So yeah, I didn't crack the whole list and leave it. I just compared in a 24-hour slice because that made the most sense to me.
Yeah.
Because if you're a security professional, you might leave it for a week or two, but usually I thought that a mean point was like 24 hours. You would start, wait till the other day passes, and then you would have your results. So in a 24-hour period, it was like 1.2 million passwords cracked by John, and it was 1.5 million passwords cracked by Unhash with combination with John. Because Unhash isn't a password cracker.
Yeah.
It interprets the rules, generates the plain text, and just dumps them on standard output. So you can type it in John, in Hashcat, or any other password cracking application that you like. The point is that the passwords that were discovered were combinations and mutations of some specific keywords from LinkedIn. Recruit 72 blue 1. Blue is the color on LinkedIn.
Yeah.
So I think it doesn't replace John, but it enables you to attack passphrases better. If you know how a person reacts, you can do a lot of more.
Yeah, in that context.
Yeah, in that context. Also, it's interesting to try some combinations with collected password lists with G-word list. So if you scrape Google with G-word list and you want to use that is usually a good thing to do, right? Yes?
I would be very interested to learn, interesting for me to learn how fast this classification is. So what you call sieving. So you put in a password, you get out the rule that generates the password. Because if it's fast enough, the whole system can be used to reject passwords, user passwords during creating accounts.
It is, it's like half a second for a password, but it could be used, yeah, but you know what's the problem with that? If you want to use sieving as a method of rejecting weak passwords, you have another problem which is called that you need to have 20 gigabytes of linguistical data attached to it. So you can't really, it's not really portable as script that will tell you, oh, that's a weak password.
So make a cloud service.
Yeah, I could make a cloud service. That one is good. Yeah, but there's another problem there. You would send all your passwords to me. Somebody would say that's a brilliant idea. No more password cracking.
Actually, that makes it really simple, because you can say, you just sent me a password over the internet. It's now unsafe.
Yeah. It's totally safe because it was sent over the internet, right? It is relatively fast, but it has a big database in the background, and the whole analysis process is therefore crippled by the length of the database, right? You can do a lot of data by it, right? There are others. You have PAM cracklib, you have other complexity requirements plugins for PAM. You can enforce them, you can pretty much tune them any way you like. But there is a problem that, I don't have a problem with password requirements, but mostly companies do really stupid stuff. For instance, in one company they have a password requirement that they need to be changed every 20 days. So what happened? Five people in the office just wrote passwords on post-it notes, and you can't use the last 5 of them. So they wrote them on post-it notes, He uses the password, and when he's done, he just passes it to his neighbor and gets another one from his neighbor. So it pretty much defeats all the process of password security, right? Because writing down passwords isn't bad, but keep them in your wallet or somewhere safe. Don't stick them up on your screen, right?
But that's about the creativity of the users. I remember a case in the 80s when the computer department set up the rules. You have to change your password once a month. The last 10 passwords can't be the same, stuff like that. Later they did an analysis and found out that nearly 80% of the people used the month as a password because it fitted the criteria, right?
Or they'll change the last number from 1, 2, 3, 4, 5, 6, 7, 8, 9, and they're going to rotate it like that. So yeah.
I'm 25 now.
Yeah. But all kinds of patterns emerge, right? Because you can't fool the user because the user is way more creative in breaking the rules than you are in setting them, right?
Can you try profiling someone's password? So if you take the passwords of one person, can you get a good enough description of those passwords so you can create personalized this person generated for the password?
I get it, but you know what's the problem with that? I can't get a data set. Those kind of people that live in the internet, that leak Adobe, Rock, use everybody's passwords on paste bin, I collect those and analyze them. But is there anybody here willing to give me all of their passwords so I can analyze?
No, but if you have your own passwords from these data sets, if you can say this person from this data set is the same person from this and this data sets.
That would be interesting, but I don't know how you would do that. See, I don't have an idea how you can connect them. Maybe if you would...
There's a username.
No. The usernames are usually truncated because of privacy.
But email usually.
But my password is in the LinkedIn dump, I checked. So, emails, most of those lists that are listed on password research or Skull Security or somewhere have their usernames truncated just because of that. First, I wouldn't want to have password lists that have users on them, because that would be a blatant violation of somebody's privacy, right? I don't have the problem of knowing that the password is 7649, but if I don't know if it's mine or hosts, I have no problem with that, right? Yeah.
It's quite interesting results, but as I can see, it's with default settings of John the Ripper.
Yeah.
But my question is, maybe if you try with some powerful rule sets in comparison
like core logic and so, yeah, they are a little bit better. But
rule set better.
Yeah, but core logic, there is core logic rule set, there is John, the rule sets that are used here are not the default John rule sets, but the community rules from Jumbo patch sets, right?
Yeah.
So they are somewhat better, it's really difficult to know what you're targeting, right? Because password cracking isn't about, you want to be global, right? You want to check out all the possible possibilities, but you can't overgeneralize it because you're going to lose time. For instance, I have the graphs and detailed sets of how John started missing. You just see that it's a search problem, right? You can see in one time that John cracks a lot of passwords and then just drops and goes into a local minimum, not finding anything. That would be interesting to watch. What are those local minimums for password crackers and when they don't start getting any passwords? So maybe they should stop deprioritize that rule and try another one, right? That would be also a very powerful addition to password crackers. So if you can't find any passwords in, like, let's say 5 minutes, pause this rule and try another one, right?
What kind of hardware?
Hardware was a simple dual-core machine on DigitalOcean.
No, without GPU.
Without GPU. GPU cracking is, I didn't try unhashed GPU cracking because I know that GPU cracking, if you have a lot of GPUs, you can use rule sets and it will be fast, right?
Yeah.
This specific tool is intended to check for things like word lists when you want to try out combinations, you want to try a rule set. Try it out.
Yeah, I will try it. And then maybe next hash runner.
Yeah,
Because one of the organizers for sure.
yeah, great. Yes?
When gathering the data set, can you get any context with the password? For example, which country it comes from?
Sorry?
Can you get the country which the password comes from?
Yeah, it was interesting because I saw, when I was analyzing, I saw a random password. I didn't know it was I saw it was a random word. Somebody just looked lowercase. And it classified it as, I don't know, Netherlands or something. And I saw that some of those random words are in fact Dutch, French, or Arabian words. So I was shocked to see that there are specifics, and there are specifics from a certain country. I think there was one password that was something like Sarma je zakon. So, you know, you can pretty much figure out that that wasn't an Englishman that wrote that, right?
Could you, for example, use that information to, I don't know, make a relation between keyboard patterns and the Germans, for example?
Yeah, that's interesting because keyboard patterns are also a problem because not all countries use the same keyboard patterns. You got QWERTY, you got QWERTY Z, you got AZERTY. Russians have, how's your name?
Cyrillic.
Yeah, Cyrillic, but it's not QWERTY, right? It's something else.
No, it's QWERTY.
You use QWERTY now. I found also one that is Cyrillic, but it's a different layout. There are like 7-8 layouts. And when you want to parse all those layouts, there are false positives. Like, I can't remember now, but some German words in QWERTY are really close to each other, so they are keyboard patterns, but they are valid German words. Also some Croatian words are valid keyboard patterns, but are actually false positives, right? The one interesting part is that you have a word list now which contains all the keyboard patterns and weak patterns that were data mined in the process. So you can use that word list, which is available there, and run it against some passwords that you might not crack. So you have default passwords, you have keyboard patterns, you have weak patterns, and you have such things in a package you can use, right? Yes?
Do you use different passwords on different systems, and can your personal password be classified as your code?
Some yes, some not. I'm, as usually the cobbler's children are the ones that don't have the shoes. So yeah, it would be stupid that I said that I don't do password reuse. I do password reuse, but I hope on important systems I don't reuse them, right? So maybe on 3 forums that are droppable accounts, I don't care about them, I reuse passwords. If you check out your passwords, you might even figure out that you do it, right? Use KeePass and generate for everything that's important, right?
Can you use cache with other tools like cache?
Yeah, it's the interesting part is that if you want to use this tool, see, the point is you just do this, py unhash rule.
You moved something.
I lost something.
And then hash you use multi-threading.
So you just install py, you use unhash py, and then just feed him the rule file. And pipe that into John with stdin, or pipe it into hashcat, which also uses stdin. There are a lot of other tools that can fetch password candidates out of standard input, so they work pretty well, so you can use that also. You can use hashcat. OCL hashcat, I don't know. I didn't try it because it was a problem because I didn't have a OCL machine for password cracking, and it was a really long story. So I did it for normal things, right?
What about Python, standard Python? You didn't use it because of GIL?
One thing is GIL. Second is there are some things like every function call adds a little bit of overhead. There were some blockings, and I couldn't optimize Python very well. So I did this, which is unfortunately, don't write bytecode. And it looks like this. It is probably the most horrific piece of code I ever wrote, and I'm probably gonna self-punish myself from that. But testing it out, I couldn't make it any faster. So I tweaked something. Is it faster? Yes, then tweak some more. If not, then revert back and try something else, right? So there are a lot of Python projects like PyPy, like Siphon, that try fast stuff, but usually you'll find they're focused on a similar other level. For instance, Siphon, I found out is fast for numerics, right? If you want to calculate something arrays, it was blazingly fast, but it wasn't fast for generating text. PyPy was the best I could find and probably did do it, but if somebody knows how to make it even faster or even better, I'm open to collaborators and contributors, right?
Plain C or what they write?
Plain C, well, I can tell you why I wrote it in Python, but I certainly won't tell it on a camera which is recorded. So it was something like, this needs to be done in 2 weeks. So yeah, I needed to do it fastly, so I chose Python. If I had the time, I would probably rewrite it in Go, because...
Good idea.
Yeah. C, when you see some design choices here, you'll see that C would be pretty much hard to port it. There are some abstractions that you can use in Python and other high-level languages that you simply cannot write in C efficiently, right? I mean, you can, but it will be a...
Anyway, I think Python is a better solution right now, because it's easy to contribute to improve by certain sites.
Yeah, but there is one other thing. This is totally irrelevant if you're attacking slow hashes. If you're attacking PBKDF, if you're attacking bcrypt, scrypt, VPA, it is totally irrelevant, because those hashes are so slow that the problem isn't in Python, the problem is in how slow the hash is, right? Questions? Anybody else?
Did you try it on iCloud?
No, I didn't, because that would be highly illegal. But I found out the password list that was used by the attacker, and he used the password list, worst 500 passwords, which I find is quite popular with people that do password cracking. Also, for instance, Configure used a list of default passwords. I analyzed default passwords on Configure and found out that they could have been at least twice as better if they used a better default password list, right? Not that they have one now, but the problem is use a good list, right? 500 worst password was pretty bad. Okay. Any other? Well, thank you. We're right on time.